So our next topic is enzyme. So enzymes, we all know. Enzymes are basically proteins, right? Proteins, then we know like they are the biological catalysts. Okay, we'll see some more properties of our enzyme. So enzyme can be defined as a compound, which is usually a protein that acts as a catalyst for some biochemical reaction. Okay, so if you are adding enzymes, what will happen? The reactions, the biochemical reactions will occur in some faster pace, right? If you are not adding enzymes, means the reaction will be slower only. So it accelerates the reaction. And for every reaction, there will be a specific enzyme. Okay, and the enzyme is specific like substrate. And the enzymes will undergo all the reactions of protein. And another properties like protein also, by heat or pH changes, our enzyme also will get denatured. And the activity of enzyme is regulated by the other components which are present in the cell. So we told like the enzymes, what they'll do, they'll speed up the reaction, right? How they are speeding up? By lowering the activation energy for the reaction. That is, for every reaction, we'll be needing some amount of activation energy, right? So when we are adding enzymes, what will happen? It will reduce the activation energy so that the reaction will occur in a faster way. Okay. So we know that the enzyme reacts with the substrate, resulting in an enzyme substrate complex will form. Then after that, what will happen? This enzyme plus product will form. So it does not affect the quality of this product, and also the enzyme also will not undergo any changes. So that is, the presence does not affect the nature and properties of the end product. Okay, and the enzymes are highly specific in their action. And for accelerating a chemical reaction, we don't need a large quantity of enzymes. We'll be needing only a small quantity of enzyme will be enough. And we already discussed like enzymes are sensitive to pH, temperature, and substrate concentration. Okay, so there is another important thing which is known as our turnover number. So turnover number is nothing but we are taking one molecule of enzyme. Okay, and we are taking like 1 minute time. So in this 1 minute of time, how many substrate molecules are transformed? So that is known as turnover number. So what is turnover number? If you are taking one enzyme molecule and if you are seeing like how many substrate molecules are transformed into product within 1 minute, and that number is known as turnover number. So that is, turnover number can be defined as the number of substrate molecules which are transformed into final product per minute by one enzyme molecule. So this is turnover number. So if we are taking our industrial enzymes, the turnover frequency will be 10 raised to 3 to 10 raised to 7 per second. So this is the turnover frequency. And the catalase, it is having the maximum turnover frequency, which is 4 into 10 raised to 7 seconds. So these things we have to know. These are important things. Okay. So we look into some of the characteristics of our enzymes, which includes
Can you please show the previous slide?
Ah, yes.
Okay, I'm done, ma'am.
Okay. So we'll look into the characteristics of enzymes. So enzymes, as we have discussed, it is very highly specific, efficient. It is having a stable structure. Another feature is like it requires some activators or coenzymes that we'll discuss in the coming slides. And if you are adding some inhibitors, the activity will get suppressed. and it requires an optimum temperature, optimum pH, and the enzyme, it can also function reversely. So these are some of the features of enzymes. This one by one we'll see in the coming slides. So this is basically, you all know what is happening during an enzymatic reaction. So our enzyme, this is structure of enzyme. So there is one site. To that site only our substrate go and binds, and which is known as the active site. Okay, so this is our substrate. So the substrate will go and bind to this active site, forming enzyme substrate complex. Okay, then after some time, what will happen? The reaction will take place. Enzyme will be as such only. No change will take place in enzyme. And the substrate will convert into product. Okay, so there's a basic reaction of our enzyme. So enzyme plus substrate, it will result the formation of some enzyme substrate complex. Finally, the enzyme plus product, it will convert. Okay, so we'll see some other important things of the enzyme. So our enzyme will be having a protein portion and a non-protein portion. Okay, and this protein portion of the enzyme, it is known as apoenzyme. So what is apoenzyme? The protein portion of the enzyme is known as apoenzyme. And this will be like inactive portion. We told like, no, we need some activators or cofactors for activating the enzymes. And that activator is known as a coenzyme. Okay, or we can tell like cofactor. This will be basically a non-protein factor only. That is, this is the cofactor. Actually, in this active side, no, this cofactor will also be there. See, it will be sitting like this only. See, this is our protein portion, that is our apoenzyme, and this is what? This is our cofactor or the activator. So this forms the active side. To this only our substrate will come and bind. Okay, so this complete thing, it is known as a hollow enzyme, which normally we'll call it as enzyme only. So the whole enzyme or the hollow enzyme is formed by the combination of apoenzyme and cofactor. Okay, so to this portion only our substrate will come and bind. So what is apoenzyme? The protein portion of the enzyme is known as apoenzyme, and this apoenzyme is basically inactive, right? So in order to activate, what we have to do, not what we have to do, like for activation, there will be a cofactor will be there, and the cofactor will be a non-protein part only. Okay, the substrate will come and bind to this active site. Okay, and the apoenzyme plus cofactor, they're together known as hollow enzyme. Okay, so this is apoenzyme and hollow enzyme. This thing, it is the diagrammatic representation of the activation energy required for the enzyme catalyst reaction and non-catalyst reaction. We told like without a catalyst, so this much activation energy is required. Okay, so if we are adding enzymes, the activation energy will be reduced. That is, the reaction will take place with less activation energy, and also the time will be less. Okay, the reaction stopped here, and without catalyst, it will take long time, and we need to supply more energy. This is just the diagrammatic representation. So as we have discussed, it is a magnitude of activation energy which determines how fast the reaction will proceed. Okay. So enzymes basically lower the activation energy and thus reduce the path of the reaction, or we can tell like it can reduce the time of reaction. So for about the mechanism of enzyme action, there are mainly two mechanisms are there, lock and key mechanism and induced fit model. So this also you might have learned in your smaller classes. So this lock and key mechanism is nothing but enzyme will be having a fixed structure, that is the lock. Okay, and so this will be, this whole is nothing, is our active site. right? Then we have to the specifics. When the specific substrate comes, that time only we can open that lock, right? So this is the lock and key mechanism, and this is proposed by Emil Fischer in the year 1890. Okay. So what is lock and key mechanism? The active site will be having the fixed, the enzyme will be acting like a lock. That is, it is having a fixed structure, and only the specific substrate can unlock the lock. Okay, so this lock and key mechanism. Another model is our induced fit model. It was proposed by Daniel Kushlands. In the year 1958. So in this, what they are telling is like, so when the enzyme binds with the substrate, when enzyme binds with there will be a change in shape of the enzyme. Not a major change, there is a minor change, like that they are telling. For example, in this, so this is our active site. So substrate is coming, it is binding. So they're telling like there is a minute change will be there. That is just like this. So it has widened a little more. So some minute change in structure will be there. Okay. So when the product, when the substrate, when the product is released, it will again come back to its original shape. So that is in this way. They are telling like when the enzyme binds with substrate, there will be some change and there will be a minute change in the structure of enzyme. So these two theories, these two models are used to describe the mechanism of enzymes. Till this, is it clear?
Yes, ma'am.
Okay, now we'll see which are the factors that affects the enzymatic activity. The major factors includes temperature, pH, enzyme concentration, substrate concentration, and the presence of inhibitors. We'll see in detail about each of the factors. And the first one is our temperature. The optimum temperature for our enzyme catalyst reactions is in the range of 25 to 45 degrees Celsius. This is also important. We just remember this value. Okay. So we'll see what will happen at lower temperature and higher temperature. So at lower temperature, the kinetic energy of the molecules will be low. So the collision frequency also will be low. Enzyme and substrate will be low. So when we are increasing temperature, what will happen? The kinetic energy also will increase. So what will happen? The collision also will increase, right? If collision increases, the enzymatic activity also increases. Okay, so what is happening at lower temperature? At lower temperature, the kinetic energy of the molecules will be very low. So the collision between the enzyme and substrate will also be very low. When we are increasing temperature, what will happen? The kinetic energy of the molecules will increase and the number of collisions will increase, and finally the enzymatic activity also increase. And the maximum enzymatic activity we can observe at 40 degrees Celsius. That is, at this point, there will be maximum amount of collisions will be there. Okay, so the maximum enzymatic action we can see at 40 degrees Celsius. So this will be this point corresponding to 40 degrees Celsius. So after this optimum temperature, what will happen? The enzymatic activity decreases because at higher temperature, the denaturation will start. That is above 40 degrees Celsius. What will happen? Denaturation will start. And at 60 degrees Celsius, the enzyme activity stops. Because what is happening? All the enzymes will be denatured. Okay. So what is that? At lower temperature, pollution will be low. So enzyme activity will be low. If you are increasing temperature, what will happen? Kinetic energy will increase, pollution will increase, enzyme activity will increase. So at what point we are having the maximum enzymatic activity? At 40 degrees Celsius. So above 40 degrees Celsius, what will happen? The protein will start denaturing. So at 60 degrees Celsius, what will happen? The enzyme activity will stop. Why? Because complete denaturation of the protein will take place. Okay. This is about the temperature. And similarly, with pH also, it is having similar behavior with like that of temperature. That is, till an optimum value, the rate will increase. After that optimum pH value, it will decrease. And the optimum pH is 5 to 9. And at extreme pH, what will happen? Denaturation of the enzyme will take place. So the next one is the concentration of enzyme. So when the concentration of enzyme is increasing, what will happen? The concentration of enzyme substrate complex will also increase, resulting in the higher reaction rate. So if enzyme is more amount of reaction will take place. So the second one is, next one is substrate concentration. So with the substrate concentration, initially, there will be sufficient amount of substrate. There will be sufficient amount of enzyme. So initially what will happen? The rate will increase. So after reaching the particular concentration, what will happen? It will become constant. Okay, so that is happening during increased substrate concentration. So as the substrate concentration is increasing, the rate increases, after which the rate remains constant. Okay, this is about the major factors which influence the rate of enzymatic action. So we have increased the action of enzymes. We'll see what we can do to inhibit the action of enzymes. For inhibiting the action of enzyme, we have to add some amount of inhibitors, right? So how we can define inhibitors? Enzyme inhibitor can be defined as a substance which binds with the enzyme. As a result, what will happen? Decrease in catalytic activity of the enzyme will take place. So what will happen actually? If this is the enzyme, means our substrate should go and bind, right? So what will do? Instead of substrate, this inhibitor will go and bind, so that our substrate will not get space to go and bind with the enzyme. So that is the mechanism behind this inhibitors. Okay. These enzyme inhibitors are also specific and they can even work at lower concentration. So they block the enzyme, but they won't destroy the enzyme. Okay. So many of the drugs, poisons, they are the inhibitors of enzymes in the nervous system. So the inhibitors can be of two types, reversible inhibitors and irreversible inhibitors. So if you are taking irreversible inhibitors, means they'll go react with the enzyme and form some complexes. That is, they form some covalent bond with the functional group of the enzyme. And as a result, enzyme inhibition takes place and the reaction cannot be reversed. So what are irreversible inhibitors? They react with the enzymes. That is, they form some covalent bond with the compounds and results the inhibition of enzyme. Now we look into the reversible inhibitors. So the reversible inhibitors, they bind reversibly to the enzyme through non-covalent interactions. That is, they won't form the covalent bond. So after inactivation, we can remove the inhibitor itself. Okay. So after inhibition, after getting the desired effect, we can remove the inhibitor. By how we can remove it? By shifting the equilibrium of the reactions. These reversible inhibitors can be classified into competitive inhibitors, non-competitive inhibitors, and uncompetitive inhibitors. We'll see the three types. So in competitive inhibitors, what they are doing is like it binds to the active site of the enzyme. So this site only, no, our substrate is going and bind. So competitive inhibitor, what it will do, it will go to the active site and bind, so that our substrate can go and bind with the site. Okay. So by binding, what they are doing, they are competing. So they compete with the substrate molecules. And also, this competitive inhibitors, they will be having molecular structures which are similar to our substrate. Okay, so this is how they are inhibiting. How they are inhibiting? They binds to the active site of the enzyme, and they'll compete with our substrate. And also they both, our substrate and this competitive inhibitor, will be having similar kind of structure. So the next one is non-competitive inhibitor. So here, no, what they are doing is like they won't be having similar structure of the substrate. They will be having no resemblance with the substrate. Here, what they are doing is like they will not go and bind to active site. They will go and bind to some other site. So either they'll go and bind to the surface of the enzyme or some other catalytically active site. So during this time, what will happen? No, our structure of the enzyme will take. So this is going and binding with some other site, or this is going and binding with the wall. So what will happen? The structure of the 3D structure or 3D geometry of our enzyme will change. So what will happen when our substrate is coming? It will get confused where I have to go and bind. Like that, it will think. So it will get confused. So that is how this non-competitive inhibitor is working. Okay. So what non-competitive inhibitor is doing? It is not having the resemblance of the substrate. It will go and bind wherever it likes. Okay. So either it will go and bind to the wall or to some catalytically active site. So by that way, it will confuse our substrate. And that way, it will inhibits the enzyme activity. So that is non-competitive inhibitor. Then we are having another one category, which is uncompetitive inhibitor. So this one, no, it is not going and bind with the enzyme. So we know like the enzyme, it will react with the substrate and results the formation of enzyme substrate. So again, what should happen? This again should convert into enzyme and product, right? So what these people are doing is like, they'll go, this inhibitor, they'll go directly to enzyme substrate and it will bind and forming some enzyme inhibitor complex. Enzyme inhibitor substrate complex will be formed. So in between, if this complex is formed, means then how it will again convert into product. So this is another way of inhibit. So this is their mechanism. So what are uncompetitive inhibitors? They binds with the enzyme substrate complex. Right? In here also, see, enzyme is here, substrate is here. Then they combine and they form the enzyme substrate complex. So what inhibitor? So this is the inhibitor actually. So these three combine and form the inhibitor substrate complex. So sorry, this is the enzyme substrate complex actually. No, this is an enzyme. So this is a substrate. So the enzyme substrate complex is this. And this is our inhibitor, right? So this is what happening during the uncompetitive. So in competitive, what they're doing, they directly go and bind with the active site. In non-competitive, what they'll do, they'll go and bind wherever they want and thus they'll change the shape. In uncompetitive, what they'll do, they'll bind with the enzyme substrate complex. So with this, we'll stop for today's class. The remaining things we'll see in our next class.
To watch the full video, purchase our course Space for Gate 2.0 only on www.acescapes.in or the AceScape mobile application.